Good morning. Since we missed a class due to snow, I thought that we'd save some time by me recording part of Chapter 8 and posting it on Blackboard. When we come back into class again, I will talk a little bit about Chapter 8. I'm going to show you a demonstration of lemon juice and what it does to apples. We'll describe browning, and we'll talk a little bit about this enzyme. But where I want to pick up here are different reaction types, and we'll have a table that I'll pull them all together in the end. But let's take a look first at reduction oxidation reactions. There are two different type of reactions, but they always occur together, and so they're called redox reactions. The first process that happens is oxidation, or they're happening at the same time, but the first one we'll describe is oxidation, which is when an atom or a molecule loses an electron. We then say that that atom or molecule has been oxidized. Reduction is the other part of the reaction, and that's when the atom or molecule gains an electron, and then we say that that atom has been reduced. As I said, these always happen together. If we want to recall ionic bonds, remember we talked about sodium and chlorine, and we said that there in the outermost shell of sodium there was one electron, and in the outermost shell of chlorine, there were 7 electrons. Let's just draw those in quickly. 5, 6, 7. And we know that chlorine, they all want 8. And so chlorine was able to steal an electron from sodium. And in that case, sodium lost an electron, and chlorine gained an electron. And when you gain an electron, you are said to have been reduced. And this sodium is said to be oxidized. So we didn't call it that before. Oxidized. But that was a redox reaction. Now, this happens all the time in our everyday life. Like if you take a look at your car when you first get it, it's all shiny and bright, brilliantly colored. And then over time, at least with cars years and years ago, you would have this happen. And this is basically rust. That's where oxygen is interacting with the materials that the car is made up of. And oxygen is causing electrons to be stolen from the car, from the material of the car. So we say that oxygen is reduced and the metal in the car is oxidized, and that leads to rust. Another maybe everyday reaction, redox reaction, is fire. In this case, the two materials or two reactants we're looking at are the wood and also oxygen. And so oxygen is stealing electrons from the wood. We say that the wood has been oxidized and the oxygen has been reduced. One way for us to remember this is to say, Leo the lion says grr. So Leo stands for loss of electrons, means oxidized, and gain of electrons is reduced. Another one that my students have told me is oil rig, and that is oxidation is loss, reduction is gain. And of course, we're talking about loss and gain of electrons. Glucose, when you consume it in aerobic cellular respiration, so let me just write that down here. So aerobic cellular respiration, which we discuss in Chapter 9, that is multiple reactions, probably 100 different reactions in which glucose is oxidized and our products are CO2, water, and we get some ATP out in the end. So glucose is going to be oxidized in this scenario, in this reaction, and oxygen is going to be reduced. Okay. The next type of reaction that we'll want to take a look at, and actually we're not going to look specifically at the reactions now, but I do want you to consider that in some cases, seeing a proton or a hydrogen indicates that there's an electron there. And so if you remember that hydrogen, oops, sorry about that. A hydrogen is a proton in the center and it's an electron in the sort of cloud. And so often when we see a molecule that has a hydrogen as a part of the molecule, that molecule is said to have been reduced because along with the proton, the molecule also has an electron. Specifically in respiration and photosynthesis that we see here, electrons, it's all about electrons being spilled out from a glucose molecule, and they need to be carried through the mitochondria and get to something called the electron transport chain. A molecule that is a carrier is called NAD, nicotinamide, adenine dinucleotide. And that molecule exists in two different forms. In one form, it has this positive charge without an H, and in the other form, it has an H on it. When you see the H, remember what we said in the previous slide. We said that the H means that you have an electron, so that would mean that you have a reduced form of the molecule. So let's go back over here. So when the H exists, it's reduced, and reduced means it's holding an electron. When we see the H missing, we say that's the oxidized form, and in this case, it lost the electron. Again, this is a process of taking electrons from glucose, bringing them using NAD into the electron transport chain, which you will see much more about in chapter 9. Okay. You can watch this web activity later. It'll talk to you about redox reactions. But I want to talk about a few other names of reaction types. The first kind of grouping here is one that is based on the word thermic. Just like your thermometer, this has to do with measuring or heat. And if you have an exothermic reaction, and let's just sort of write the reaction down here. A plus B yields C plus D. And I'm going to say here that D is heat. If you have an exothermic reaction, heat is going to be on the right side of this reaction. It is going to be a product. And we also, related to this, say that the products have less energy than the reactants. So the remainder of the product, so C, has less energy than A and B do combined. Exo, think about it exit, think about it leaving. And so heat is leaving this reaction. That is exothermic. I'm going to show you something else about remembering how products have less energy later. The next one, of course, may be linked to that is an endothermic reaction. Again, it's thermic, so it has to do with heat. But on this case, the heat is going to be on the side of the reactant. So it would be heat plus the reactants yields products. And in this case, the products have a greater amount of energy than the reactants. A similar type of reaction with similar names has to do with energy as a whole, not necessarily just heat energy, but any kind of energy. And those two are called exergonic and endergonic. Exer is just like XO. It's when energy leaves the reaction. And endergonic is when energy enters the reaction. So in this case, energy would have to be on the side of the reactants. And in this case, it would be on the side of the products. These happen, as you can see with these two gears, these happen together. One reaction that requires energy to be put into the reaction hooks up with a reaction that gives off energy as a product. Now, if we take a look at reaction types and a table, see if I can pull for you that table. So if we now go to your course materials under chapter 8, I put this reaction table. Let's open that up. And you can see that I pulled together not only the reactions that we discussed today, but also I added in the condensation and hydrolysis reactions. So this is just the reaction type, some brief description of what it means, and then also a little more of a description. One thing that I do want to point out to you that reactions, a single reaction could have more or be more than one type. So in the case of this overall cellular respiration reaction where we get glucose plus oxygen yielding CO2, water, and energy, this is an example of oxidation, of reduction, and of an exergonic reaction. So in this case, glucose will be oxidized, oxygen will be reduced, and you can see we have energy over here leaving the reaction on the product side, and so that's called an exergonic reaction. I hope this helps.